All right, so we're going to determine the relative extrema of this hyperbolic function, and here we go. So the derivative of hyperbolic functions are pretty similar to your regular trig functions. Just be careful of the signs. You'll see. So anyhow, you're still following all the rules of differentiation, obviously. So the first part of it is a product rule. So it's the first times the derivative of the hyperbolic sine, which is hyperbolic cosine, and then times the derivative of the inside. The derivative of x minus 1 is 1. So I'm done with that, the first part of the product rule. So plus the second hyperbolic sine times derivative of the first, which is the derivative of x, which is 1. So I'm done with this first term. Now I have to take the derivative of the second term, which is just the derivative of hyperbolic cosine. The derivative of hyperbolic cosine is positive sine, so it would be minus positive hyperbolic sine of x minus 1. That's it. So this works out nicely because you can see those hyperbolic sines will cancel out, and I'm left with finding the zeros of this. So hyperbolic cosine I'm not too familiar with. So I'm going to change this to its exponential form. Its exponential form is e to the, is e to the x plus e to the negative x all over 2. So we have to figure out where this expression is 0. Obviously, it equals 0 when x equals 0, and it's going to be 0 when e to the x plus e to the negative x equals 0. But those are both exponential functions. E to any power is always positive. So we have a positive plus a positive up top, which will never be 0. So that's it. The only critical number is x equals 0. So I'm going to go to my first derivative test and check out f prime of, say, negative 1 and f prime of 1. This is easy because remember, this part is always positive. So you just plug in the negative 1 and the 1 in the x. You obviously get a negative and a positive, which means we have a relative minimum at 0, comma, plug it into the original function. So we have 0 times the hyperbolic sine, which is 0, minus hyperbolic cosine of negative 1. All right, so let's quickly check this on the calculator. First thing I'm going to do, I pre-wrote this here. Hold on a second. I have to find my calculator. So the hyperbolic cosine is still, it's going to be negative e to the negative 1 plus e to the negative 1 over 2. So 1/2 e to the negative 1 plus e to the positive 1. That's this part, which is the hyperbolic cosine of negative 1. And that turns out to be negative 1.543. So the reason why I want to do that is I want to make sure I was correct. I'm going to check this on the calculator. So I'm going to graph the original function. Now you get the hyperbolic sine and hyperbolic cosine from the catalog. Down here, second catalog. And then you can just shortcut it, use your letter key like S to get the hyperbolic sine quickly. But anyhow, the graph looks like this. It does have a minimum. It looks like it's at 0. So second calc minimum, left bound negative 1, right bound positive 1. Guess is enter. And I'm getting 0 for x, and then negative 1.543 for y, which confirms my answer. Negative 1.543 right there. So I'm very satisfied with the relative minimum being exactly right here. That's all there is to it.